Good morning, students. Hope you are all well and taking care of yourselves. Today we are going to study periods and electronic configuration. First, we'll see what is the meaning of electronic configuration. The distribution of electrons in the different orbits or shells of in an atom is its electronic configuration. For example, if you take lithium, lithium has atomic number which is represented by Z equal to 3. Its electronic configuration is 2, 1. As you can see in the diagram here, lithium, the nucleus is surrounded by two orbits. The first orbit contains 2 electrons and the second orbit contains 1 electron. The electron capacity can be found out by using the formula 2n square, where n is equal to 1, 2, 3 and 4. In the diagram, you can see the first shell, that is K, its capacity is 2 electrons. When n value is taken as 1, we get answer equal to 2. The second shell, L, has capacity of 8 electrons. M has a capacity of 18 and N can hold 32 electrons. Gradation in the periods. While going from left to right within the period, the atomic number increases by 1 at a time, and so also the valence electrons. Now, what are valence electrons? They are the number of electrons present in the outermost shell. For example, if we take period 3, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The electronic configuration of sodium is 2, 8, 1. That is 2 in the K shell, 8 in the L shell, and 1 in the outermost shell. And as the electron atomic number goes on increasing, the number of valence electrons in the last shell go on increasing up till 8. Now, the periodic trends in a modern periodic table. What do you understand by periodic trends? When the properties of elements in a period or a group of the modern periodic table are compared, certain regularities observed in their variations. This is called as the periodic trend. We are going to consider three properties, namely valency, atomic size, and metallic and non-metallic character. The first one is valency. The combining capacity of an atom is known as its valency. The number of bonds that an atom can form as a part of a compound is expressed by the valency of the element. For example, if we take the gradation of valency down a group, let's see group number 1, 2 and 18. The valency down a group remains the same. In group 1, the number of valence electrons is 1. If you take for hydrogen, lithium, sodium, potassium, the valence electrons is 1 and therefore valency is also 1. Second, in group 2, the number of valence electrons is 2 and the valency is also 2. In group 18, we have all the inert gas elements, helium, neon, argon, krypton, xenon and radon. Their valency is 0 because they are stable. The electronic configuration is stable. Next, the atomic size. As the name suggests, it is the size of an atom. How do we measure the size of an atom? The size of an atom is indicated by its radius. Atomic radius is the distance between nucleus of an atom and its outermost shell. It is expressed in the unit called as picometer, which is smaller than nanometer. The atomic radius goes on decreasing while going from left to right within the period. And while going down the group, the atomic size goes on increasing. Let us see in the diagram here. Along the period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, as you can see, the size goes on decreasing. Now, though the electrons go on increasing, the size is decreasing. Now, what is the reason for that? The reason is that the electrons go on adding in the same shell. Therefore, the positivity of the atom increases. But at the same time, the nucleus is attracting the electrons towards itself, and therefore the atom size decreases as we grow from left to right. Let us see what happens down a group. Lithium, sodium, potassium, rubidium and cesium. As you can see in the diagram here, the size of the atom goes on increasing as we go down a group. Now what is the reason? What is the explanation for that? Here, as you see, the number of shells in the atom go on increasing, and therefore as the shells increases, the size of the atom also increases. Therefore the gradation down a group is the atomic size goes on increasing. Homework: learn all the definitions and the periodic trends and answer the questions asked in the textbook on page 23, 24 and 25. Thank you.